Alright, so this is a walkthrough on how to complete the data coding for the Facesheet. So this is after the initial article data has been extracted by the RAs, and then putting it all together into the Facesheet and then finalizing it and adding it to the master list. So what I'll do is first step is I'm going to open up the meta-analysis workflow and assignment sheet. I'm going to look for my initials, and I'm going to figure out which article I'm assigned to. So for illustrative purposes, I'm going to be working with article 7/2010, just because the data structure is a little bit easier, so it'd make the video a little bit easier for demonstration purposes. So I'm going to see my initials. I'm going to come across. I'll see that it's been the data has been initially extracted, and then it's been double coded, so it's good to go. So I will open that up, and the initial coding sheet is exactly mirrored of what the data sheet looks like for the Facesheet. So all you have to do is copy and paste this into the specific cognitive domains, which I'll show you how to do that in a moment. So it's been coded, it's good to go. I'm going to open up the dissertation code sheet. And then I will save it right away. I will save it onto the OneDrive. That's not right. I want to save it under the TBI meta-analysis, data entry, completed code sheets. And I'll save it under this following nomenclature. So I've already done this, but it would be the article code dash data code sheet and then my initials. So what then I'll do is open up the actual article. So this is the actual article. It's by Shrefu in 2010. My first step is typically I read the abstract just to get a sense of what the article is looking at, what the results are, just so as to have a sense of the population, so I can kind of get that moving on in my mind. Also, once I look at the effect size after everything's extracted, if something looks really, really off and compared to what they see in the results, that might tick me into the right direction, set off kind of a light bulb or an alarm of, okay, maybe I did something wrong or I didn't copy and paste something. So after I read the abstract, I just scroll down to the methods. There's really no reason for me personally to read the introduction, probably not for you either, and then I'll just read the most of the methods. As you go through, feel free to highlight, write notes, whatever you want to do, save it to the shared drive. As I went through the initial data coding, the initial coding for the second time around, I went through and I highlighted anything I saw that was pertinent that I know that you'll want to extract later. So that's hopefully going to make your lives a little bit easier. I also have highlighted the tables on every single Excel sheet, every single article. That is how the RAs know what data they need to extract. So that's already been done for you. However, there may be some things that I missed, in which case you would need to hand enter. Or if there's something within the results section that I didn't see because it wasn't in a table, you'll want to make sure to include that as well. So just be aware of that there might be some other things that you would need to enter. But for the most part, the bulk of it has been done by the RAs already, which really reduces the time for doing these data codings. I think I was able to do an entire article in about 20 minutes or so, and I only imagine that's going to go faster. So we have our data code sheet over here. We'll start out by putting the study code, which is going to be 7/2010. The author, so I'm going to do the last name, SROUFE. The year is 2010. The country is, I think this is USA, done in the USA. Yep, University of Michigan. So country, USA, and I'll confirm that once I go through the methods. Typically what I do is I start by going through all of this stuff first, and then I go through and I copy and paste the neuropsych outcomes. But for the purposes of this video, I want to make sure to show you how to do the neuropsych outcomes, because I think that's most important, where the bread and butter is for this. So I'm actually going to show you that first and do it in the reverse order of how I typically go about coding this. So as we see from down here, we have an independent groups post-test only. So I will come down here, independence groups to post-test only. Sorry, let me pull open this one here. So what the RAs do is they literally just copy and paste exactly what they see on the tables here. So PCSQ, simple digit modality test, trails, RAVLT 1 to 4, RAVLT trial 6. So what you have to do is you have to go through and decide what cognitive domain each one of these tests fall in. So that is kind of your decision and what you have to do. And so you'll do that by looking at the method section and making that decision. So I'm going to come up here and I'm going to look for the PCSQ because that's something I'm not super familiar with. And so that's post-concussive symptom questionnaire. So fantastic. That's obviously assessing post-concussive symptoms, which is something that we have that we're measuring and gathering effect sizes for. One thing you will want to be super certain about and be very careful about is that how they're measuring the outcome measures and the direction in which it's being measured. So for example, this is trail making test B, right? So generally that's measured in reaction time, in which case if you have a higher reaction time, that's actually worse. But if we come down here to the actual tests, the mean score is 0.32 plus or minus 1.26. So that's obviously not a true, that is not a reaction time or a measure in seconds. So I look here and it actually shows that it's a normalized score or a z-score. So in this case, unlike what we would do with a typical trail speed, having a higher score is actually better and having a lower score is worse. Now, if it were the other way around, so for example, reaction time. So let's say that this is reaction time where higher score is worse. What you would do is come over here and click this box. And what it's going to do is it's going to automatically change the direction of the effect size, where having a high score is now actually worse. It's going to reverse the sign of it. And you'll want to do this in the actual data face sheet, not necessarily right here, but you can if you want to. So let's get to work. So PCSQ is the number of symptoms, and I know that because I already looked at it and checked it. So this is 1.42 symptoms. This is saying at baseline, but when you read the article, you actually see that baseline is 24 hours after the initial TBI. So it's not a true baseline. It's not a pre-morbid, pre-concussive baseline. So this is our time point 1. So 1.42 symptoms. So in this case, having more symptoms is worse. So this will be a great example of having to reverse the sign. So what I'm going to do is I'm going to come over here. I'm going to copy this. I'm going to switch over to my face sheet. I'm going to scroll down until I get to the very bottom because that's where PCS is. So we only have one outcome measure. So I'm going to copy and paste that right there. Notice how it's calculating an effect size for me. However, remember, in this case, having higher PCS is worse. It's a worse outcome. So the MTBI group should have we need to reverse the sign for this. So what I'm going to do is I'm going to check this box. Now all of a sudden, this is representative of the direction of the effect size that we want. So a higher effect size means worse outcomes for the MTBI group. So I'm going to come over here, copy this. I would not recommend, do not copy this actual data right here. Just copy this information right here within the actual tables. The reason for that is that if you click here, you can see that it has all this code based on other things. So if you copy this as well and then transfer it over, it's going to screw up the actual calculations. So don't do that. So I'm just going to copy the numbers, and I'm going to put this over for time point 2. Now again, because this is checked, it's automatically going to reverse the sign for this effect size measure too. So if you check this box, it's reversing it for everything for all 6 time points. So you don't only have to do that once. And finally, coming over to time point 3, switching over, copying and pasting this bad boy into time point 3. All right, so now we're done with PCS. So now we need to do simple digit modality, which is a measure of processing speed. And again, you would think, so single digit modality is the dependent measure is how many things you're completing or how many of the items that you're drawing. So higher score is actually better. So we don't need to worry about reversing anything. So again, I'm going to copy here, paste. It's calculating it automatically for me. Copy, and I'm going to paste. And then last one for 10.3, I'm going to scroll over, copy and paste. So again, because of what the RAs have done, we do not have to go through and actually extract this data from the articles, which is going to make our lives so much easier and a lot quicker. So we're going to do the same process for Trails B as well as RAVLT. Now, there are differences in memory. So you have an immediate memory and then you have a delayed memory. So again, you're going to have to use either consult what you know clinically, consulting with LESAC, or whatever is mentioned specifically in the article of how they define it, of what cognitive domain that they're actually assessing. I believe they don't differentiate immediate and delayed. With the RAVLT, they just have it as 2 outcome measures, but we want to specifically delineate those immediate and delayed. So what I'll do is I'll come through here and I'll put the RAVLT trial 1 through 5 as immediate, and then the trial 6, which is after the 20 to 30 minute delay, as delayed memory. So I'm not going to go through all of that just for the sake of time of copying and pasting all the different time points. I just want to do that for illustrative purposes. So coming back to the face sheet, none of the actual information is going to be copied over until you select the specific experimental design. I wanted to move this up earlier in the Excel sheet, but to do so at this point would require way more coding than is necessary, so I'm not even going to bother. So just know that you're not going to actually see the results until you click down here, but independent groups design post-test only. Now all of a sudden you have your effect sizes. Coming down here, you also have your effect size for the PCS right here. So you have your 3 different domains. You have your observed D and your standard errors, and it's going to copy all that into the all data merged over here as well. So that is perhaps the most important part of this process, is making sure that we get these effect size data here. The next part is just putting in actual information from the study. So whether or not there's an appropriate method of defining TBI, in this case, I'll say yes, and that's because I read the article and I highlighted. So it's defined by the ACRM where they cited it. So in this case, they don't actually, I don't think they specifically say the ACRM, but when I scroll down to these citations, I saw that they specifically cited ACRM. So I'll just say ACRM. The quality of the diagnosis, again, from reading it, I know that they had a medical professional diagnose it later. So nobody observed it directly, but it wasn't just based on self-report after some 20, 30 minute, or 2 years down the road. They came to the ED and they were diagnosed. So it meets standard definition. It was diagnosed later by a medical professional. This was not an imaging study, and they did use the TOM to determine whether or not there was sufficient effort. So they did use it to exclude invalid performance. The TOM is a standalone measure. The control group was a orthopedic control, I believe. This was not, in reading the methods, it didn't indicate that this was part of a larger sample or a larger study. So for example, McRae uses a lot of the same information or data from that huge football database, in which case you'll see maybe 30 people where they had MRIs, but it comes from this larger database. If that's the case, you want to indicate, yes, this is coming from that larger study, because we don't want to count those data twice. So we would need to go through and be very careful about whether or not which of the studies, if it's coming from the same article, we're going to use, or if the data are sufficiently different. So that's kind of a methodological decision we're going to have to make down the road. So it's not part of a larger study, so on and so forth. There are certain things where, for example, I don't even remember. So we have the age category here, where once you put in your mean age, I think the mean average age of our kiddos was something like 12 or 13. So the mean age was 13.50. So that's like, all right, is it, whoops, mean age 13.50. The age category, I'm like, all right, well, is that middle school? Is that high school? I don't remember. I don't know. What I'm going to do is I'm actually going to go to the data entry code book, and I'm going to scroll down until I find that specific variable of interest. So age category. So the average age is 13.5. So the children they'd be children if they're 0 to 13, high school if it's 14 to 22. And in this case, I'm going to use a little bit of a judgment. So if I'm looking at the range of children from 10 to 17, the average is 13. I feel like it would be a little bit unfair to capture the high school to children, because then obviously we have our 10, 12, 13, 14-year-olds who are being misclassified. So I'm going to be a little bit conservative, and I'm just going to do it as children. Sorry, Facesheet. I'm going to select them as children. And again, this is something where it's one of those you got to make a call. And if you're not sure, put it on the team's website, put in the information. We're going to make that decision together as a group. There's going to be certain things that you don't know or they don't include. So for example, with the population, we know that there are 86% white. So 86% is white, which means that the other is 14% non-white, so non-white 14. But we don't know how many black, so we're going to do negative 99. We don't know how many Latino. We don't know how many other race, so we're just going to do negative 99 for those. Mean education, pretty straightforward. So in this case, they do they don't give an average education. They do the percentage of people who are in regular schools system and how many are in special education. So we don't know what the average age is, or average education. So we'll do negative 99%. Female, sorry for jumping all over the place. That's 43%. Mechanism of injury, sometimes they have it, sometimes they don't. If we don't know, then we will just leave it as negative 99. We do know that there are 11% who have ADHD. So I'll come down here, 11% ADHD. There are 12% that had, 19% that had a previous TBI. Could have sworn that was something somewhere. I guess not. Oh, here we go. Previous TBI. That's 19%. So again, I apologize. I'm jumping all over the place. I'm just trying to illustrate some of these more nuanced things. These are all pretty straightforward. So obviously, none of these kiddos are veterans, so we can put 0% for a veteran. We don't know. If you don't know, for example, how many of them fell, I think they have this somewhere, but I can't remember. I apologize, bear with me. Okay. In this case, right away, I don't see mechanism of injury. I just know that they presented the ED. So if you don't know for sure, you can just do negative 99 for these. Sometimes you'll see, for example, one of the articles I coded already, they were all athletes and they all played football. So that's an impact sport. So right away, I knew that this was going to be 100%. And everyone else, I knew right off the bat was going to be 0% because literally 100% sustained a concussion because of impact sport. But if you don't know and it's not listed, be conservative and just do negative 99. It's better that we have that missing data versus false 0, which could potentially influence the outcome of our results. One other thing I wanted to bring your attention to is the composition of the sample site comorbidity. So this one's a little bit tricky. If they do not specifically rule out all psychological comorbidities, then you, and they do not, and it's not 100% sample of like all folks with depression, all folks with PTSD, then you're conservatively going to put the composition as mixed. If they do exclude based on depression, anxiety, PTSD, LD, ADHD, all of those things, then you can put 0%. But otherwise, we're conservatively going to say it's going to be a mixed group, or if it's specifically recruited based on depression, anxiety, PTSD, so forth, then it would be 100%. Hopefully that makes sense. So I'm going to skip the rest of this. I'm assuming that this will all be pretty straightforward. Again, you can refer to the code sheet if you don't have any information, if you're not certain, or if you want to consult with me, put it on the team's website so everyone else can see. Once this is all said and done, everything is coded. You're going to come to the all data merged. You're going to copy this, and then you're going to go to the master database, and you're going to paste it. But when you paste it, make sure that you paste special with just the numbers. Again, the reason for that is that if you don't paste special, it's going to bring all the code with it, in which case we don't want to do it. So you'll copy it, and you'll make sure that you paste special with the numbers. So 1, 2, 3. That way it eliminates all of the specific code. So notice how this one has code here. It's going to eliminate all of that, and it's just going to put the actual numbers that you see. Hopefully this makes sense. Hopefully this is pretty straightforward. I imagine there's going to be a little bit of a learning curve. Please go through and code this one as well, just for practice. So this specific one, 7/20/10, just so we can all get on the same page and you have some experience with that. And then that way you can compare it to the results I have. If there's anything where there's discrepancies, let me know, and I'd be happy to talk that over and make sure that we're all on board with that. Thank you so much, and I'll be tuning in to show you more videos of what to do when there are complex cases or there's multiple subgroups, things like that. Take care.